All right, so in studying systems of linear equations, we are going to first talk about what a linear equation is, how to graph them, and then what finding the solution to a linear system of linear equations actually means. So a linear equation consists of terms that are either a constant or a constant multiplied by a single variable to the first power. An example of that in general form is ax plus b equals 0. And so we have either a constant, which is this one. This would be represented by just a number, which is 8 in my example over here, and or a constant multiplied by a single variable, which is this constant multiplied by our single variable here. All right, equals 0. It can equal another number as well, but simply we just make it equal 0 at this point. Now, you'll notice there's only one variable in this equation. We're going to first talk about how to deal with linear equations that have only one variable, either x or y. And in this example, we're going to look at 4x minus 8 equals 0. We would like to graph this line. All right, lines consist of points x, y, and values at x, y, when added or when input into the equation together, they form a line. And so, or they satisfy the equation and they all line up. So let's take a look at this. If we solve this equation right here, 4x, all right, so 4x minus 8 equals 0. Let's solve for x. 4x equals positive 8. X equals 8 over 4. X equals 2. So we found out that x equals 2. Well, in this line, what that is telling us is that every single ordered pair that is a point on this line, x must equal 2. This equation does not have y in it, and therefore y can be any value. So let's look at some points that satisfy that. One point would be 2 for x, because x must be 2, and 0 for y. Another one is 2 for x and minus 1 for y, or 2 for x and 2 for y. So see what I've done. This first value, which is our x, must be 2. Y can be anything. It is not in this equation. Now let's see what that looks like when we graph it. Okay, so I've drawn myself a coordinate axis and I'm going to plot these points. 2, 0. So the point 2, 0 is 2 on the x, 0 y for the y, so that point is right there. And the other one, 2 minus 1. We go over 2 and down 1. We'll plot that point. What about 2, 2? So over 2 and up 2. Okay, have you started to see the pattern here? That every x value in these points is 2. The y could be anything, so our up or down is anywhere along this line. And so when we go to graph the line, it actually looks like this. Okay? Right there. All right, so that has formed a vertical line passing through x equals 2 on the x-axis. And actually, any linear equation with x as its only unknown, when you solve for x like we did here, it will produce a vertical line passing through whatever that x value is. So in general, that's what we can say about linear equations with x as their only unknown. Okay, here's another practice for you. Try graphing the line 3x plus 3 equals 0. Notice we only have x as a variable. There isn't a y in this equation, so y can be anything. I want to keep that in mind. Use the same approach. Solve for x and plot points that have that x value and any y value. Pause the video and try that yourself. Okay, so back to it now. If we solve this equation for x, we get that 3x equals minus 3. X equals negative 3 over 3. X equals negative 1. So, for example, some points. Negative 1, 0. Negative 1, 2. Negative 1, negative 3. As long as our x is negative 1 and our y is anything. Let's plot those points. So negative 1, 0. Negative 1, 2. Negative 1, negative 3. And now we will draw the line through those points. So we have a vertical line passing through x equals negative 1. Vertical line passing through x equals negative 1. Okay, and this pattern will happen every time we try to solve a linear equation with x as the only unknown. Okay, the other type we might look at is a single variable, but the variable is y. So that means that we don't know anything about x. So x can be any value this time. We will use the same approach. How about we solve the equation for y, which gives us 2y equals negative 6, y equals negative 6 over 2, or y equals negative 3. If y equals negative 3 must be in every single point, and x can be anything, then an example of some points will be something negative 3, something negative 3, something negative 3. They could be 3, negative 3, 0, negative 3, minus 2, negative 3. Let's graph them and see what they look like. So, over 3, down 3, 0, negative 3, negative 2, negative 3. When we connect those to draw the line, it looks like this. Okay? So instead of having a vertical line, we now have a horizontal line passing through negative 3 on the y-axis. Okay, so those are two special cases I wanted you to have a look at, what to do and how to graph a linear equation with x as the only unknown and y as the only unknown. So linear equations with x as the only unknown produce vertical lines, and linear equations with y as the only unknown produce horizontal lines. Okay, now we will now look at linear equations involving x and y in their equation. The general form of a line is ax plus by equals c, and this is a multiple of x plus a multiple of y equals a constant. And this x and y together are ordered pairs that are points on the line. And there are actually an infinite number of values that will satisfy every linear equation, because you can always pair up a y with every x for each line. And so, we will be looking at now 2 ways to graph these lines and find out what they look like. Unless A or B is 0, we don't have situations like we just saw. And we will have all other lines, not verticals, not horizontals. So let's see. Let's do an example. I will put on 4x minus 2y equals 10. We're going to look at 2 different ways to graph a linear equation from general form. So, one of the things you want to note about all linear equations is that, or all lines, they pass the x-axis once and the y-axis once. So these are key values. Let's do a quick little diagram of x and y axes. If I plot a line on here, and I'm just going to draw a line. Okay. Notice that we have passed the x-axis once and the y-axis once and the x-axis once. So these are what we would think of as key points, okay? If we can figure out these 2 points for this line, 2 points determine a line. And so what do we know about each of these points? For example, this point here, as far as its ordered pair that make it up, we don't know how far over we went in the x, but we do know that if this is on the x-axis, that the y value must be 0. So this point is, let's just put another color in there, this point is something 0. And similarly, this one, we do know that we've gone down a certain amount of y, which we don't know what that number is. But we do also know we have not gone left or right, so the x value must be 0. So these are called the x and y intercepts. Okay, the x-intercept occurs when y equals 0. The y-intercept occurs when x equals 0. So this will give us 2 points. If we sub y equals 0 into this equation and solve for x, we will get the x value that goes with y being 0. If we sub in x equals 0 into the equation, we will get the y value that goes with x being 0. Once we have 2 points, we plot them and we have the line. So let's do this example. Okay. To find the x-intercept, I want to sub in y equals 0. So 4x minus 2 times 0 equals 10. That gives me 4x. This is all 0. So 4x equals 10. X equals 10 over 4. Or x equals 2.5. Okay, that means x equals 2.5 goes with a y value of 0. So a point on our line is 2.5, 0. And we go over to our graph and let's put that point on the line. 2.5, 0. Great. I want to do the same thing to find the y-intercept. Okay. 4x minus 2y equals 10. We were going to find y-intercept. we sub in